It's Zach, and today we're talking about relays, so enjoy. And don't forget to like, subscribe, and click on the notification button for more electronics videos. A relay is a switch that is triggered by an electromagnet. But what does that actually mean? Let's look at a diagram that explains this. A mechanical switch is used to close a circuit with a power source and an electromagnet. Once the electromagnet is turned on, it pulls the movable armature or switch into the closed position as shown in the below diagram of a normally open relay. For a more in-depth discussion about what normally open and normally closed means, check out my video about electronic switches. A normally closed relay shown below also uses a mechanical switch and electromagnet to activate the relay. However, in a normally closed relay, the electromagnet pulls the switch into the open position. Before moving on to key characteristics of a relay, it's important to go over the basics of an electromagnet. Electromagnets are used in many other electrical applications, such as transformers and motors. Therefore, a quick foundation of electromagnets will serve you well in your future electronic studies. An electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Naturally, current creates a magnetic field as shown in the diagram below. However, the magnetic field around a single straight wire is too weak to work as an effective magnet. The strength of the magnetic field can be increased by wrapping the wire into a coil, but in order for the electromagnet to be strong enough, the coil needs to be wrapped around a ferromagnetic core. A metal that is ferromagnetic has many small electromagnetic domains. When no current flows around or through it, these domains face in many different directions, canceling each other out. However, when the ferromagnetic material is exposed to a magnetic field, the domains align with the field while strengthening it enough to be used as a magnet. Hence, an electromagnet is a ferromagnetic core with a coil of wire wrapped around it that activates when current goes through the wire. The strength of an electromagnet can also be increased by the following ways. 1. By increasing the number of turns in a coil. 2. By increasing the length of a coil. 3. By increasing the amount of current flowing through the electromagnetic coil. 4. By using a different ferromagnetic core material. Some materials produce a stronger magnetic field than others. Now that we have discussed the electromagnet that is a necessary component of a relay, let's talk about relay key characteristics. The coil voltage is the voltage that a relay is supposed to use when you energize it. AC voltage or DC voltage may be used depending on the relay specifications. The set voltage is the minimum voltage that the relay will accept to close the switch. This will be a bit less than the ideal coil voltage. Basically, the relay will still close using the set voltage. However, it will do so more slowly than if it uses the specified coil voltage. This is not good because it increases the likelihood of arcing that can damage the relay or increase the likelihood of noise that can affect the functionality of the circuit. Operating current is the current consumption of the coil when the relay is energized. However, there are limits to how much current a relay can handle, and that threshold is specified by the switching capacity. When the switching capacity limit is exceeded, damage to the relay is likely to happen. An electromagnet works when current flows through it and stops working when the current is shut off. Therefore, a relay is electrically held when it is held in place by the electromagnet. However, a relay can also be held mechanically in place by a built-in locking mechanism. With this device, the relay will be pulled into place by the electromagnet, but will be latched there by a mechanical system. This means that the mechanically held relay will still be actuated even when the electromagnet is turned off. The relay becomes deactuated by a current through the electromagnet on the other side, or when a pulse is received in the opposite direction. Now let's talk about how relays can be used. The first way is that relays can actuate multiple circuits while only using a mechanical switch. What I mean is that one mechanical switch can turn on a circuit that actuates two or more relays. Each relay then actuates the circuit. Therefore, you can easily turn on multiple circuits at the same time by using relays. A relay can also be used as a current relay. A current relay is designed to trip when certain levels of current are presented in the control circuit. By actuating when the current reaches too high a level, it can protect the system from damage caused by excess current. When the relay senses that the current is too low, it can trigger an alert letting the engineer know something is wrong with the electrical system. Relays can be set with a time delay. This delay can be set for a time period as small as a few microseconds to as large as minutes, depending on the application. A good use of a time delay relay is when it's used to prevent a breaker from tripping. It does this by staggering the activation of multiple pieces of electronics equipment that need to be used at the same time. Through the staggering of equipment, the breaker doesn't get overloaded by the inrush currents required to turn on each piece of equipment. Hence, the breaker won't trip unnecessarily. Before moving on to the next relay application, let's briefly talk about what an inrush current is. An inrush current is the current required to turn on a piece of electrical equipment. Just as it takes more energy to push a box on the floor from a resting position than it does when the box is already moving, it takes more current to start a piece of equipment than it does to keep it running. For example, a motor that needs 5 amps of current to run may need 10 or more amps of current to get started. Momentary contact relays are just like typical electromagnetic relays, except for the fact that they actuate only for a moment before returning to their normally open or normally closed position. It's ideal to use this type of relay in equipment that requires a momentary burst of energy instead of a constant one such as a motor starter. Relays, called coaxial relays, are used in antenna applications to direct radio frequency or RF signals from one path to another. Where radio transmitters and receivers share one antenna, a coaxial relay is used to switch from the receiver to the transmitter and vice versa. The coaxial relay, unlike others, is designed not to reflect any RF back to the source, hence enabling effective antenna communication. Hey everyone, I hope you enjoyed this video, and don't forget to like, subscribe, and click on the notification button for more electronics videos.